Lesson 5.2, Sequences. A sequence is an ordered list of numbers. Each number in a sequence is called a term. In an arithmetic sequence, each term is found by adding the same number to the previous term. So, if we turn to the next page, and we go down to the got it part, our directions say, describe the relationship between the term in each arithmetic sequence. Then write the next three terms in the sequence. So first what I have to figure out, what am I adding by every time? Because our directions say it's an arithmetic sequence, and arithmetic means we're adding the same thing every time. So in letter A, I have 0, 13, 26, 39. So I ask myself, how do I get from 0 to 13? I add 13. So then I got to try that again. What's 13 plus 13? That's 26. 26 plus 13 is 39. So I know that in letter A, I'm going to add 13. Then it asks for the next three terms. So 39 plus 13 is 52. 52 plus 13 is 65. And 65 plus 13 is 78. Okay? I'm going to look at letter D now. I have 2 and 5/10, 3, 3 and 5/10, and 4. So again, I ask myself, what am I adding by every time? How am I changing here? Well, from 2 and 5/10 to 3, I add 5/10. From 3 to 3 and 5/10, I add 5/10. And then to get to 4, I add 5/10. So I know I am adding 5/10 or a half every time. So then I continue on. 4 plus 5/10 is 4 and 5/10. 4 and 5/10 plus 5/10 is 5. And 5 plus 5/10 is 5 and 5/10. Okay? The next thing we are going to do is we are going to write an algebraic expression using our sequences. So we can figure out what's the nth term. If I were to ask you what's the 102nd term, you would be able to tell me. Okay, so example E. If the pattern continues, what algebraic expression can be used to find the number of circles used in the figure? How many circles will be in the 50th figure? So first of all, I have to figure out how many circles do I have. In figure 1, I have 3. Okay? In figure 2, I have 6. And in figure 3, I have 9. So when we're trying to figure out our expression, the first thing we do is, what are we changing by every time? What are we adding every time? Well, to get from 3 to 6, I added 3. From 6 to 9, I added 3. So my algebraic expression is going to start off with 3 times n, because that's the position. Our n is always going to be our position. So, or in this case, what figure do I have? What position am I at in my sequence? So now that I have my expression, I'm going to test it to see if it actually works. So this is figure 1. So I'm going to put 1 in for 3. 3 times 1 is 3. So it works there. Then I put 2 in. So I take 3 times 2. I get 6. Okay, I try it again for figure 3. 3 times 3 is 9. So this, in fact, is our final algebraic expression. Now, sometimes it's not going to work like that. You might have to add a number or subtract a number. So after I have written my algebraic expression, then it asks me how many circles can be in the 50th figure. So now what I'm going to do is I'm going to substitute 50 in for n, because n was our nth place. So now I have 33 times 50, and 3 times 50 is 150. So in our 50th place, we would have 150 dots.